Example 26. A beam is subjected to a system of loads that can be represented by the load diagram shown in the figure. Determine the resultant of this system of loads and locate its line of action with respect to the left support of the beam. So from A. Okay. So we know that the resultant force F sub R is equal to A, right? And our A, let me adjust this. And our A is equal to the integral of our WDX, right? Whatever our weight that is, right? So we take, in order for us to know our W, we take a small strip here. It can be anywhere, right? Small strip, which has a length of the X, and this is our W. Okay, so if our equation is represented by W sub max sine pi x over 2L, so this is A is equal to the integral of W sub max, what maximum load times sine pi x over 2L dx, right? So if FR is equal to A, then A is equal to the integral of W max sine pi x over 2L dx, then F sub R, therefore, F sub R is equal to the integral of W max sine pi x over 2L dx. And we are going to integrate that from over the entire length, which is L. Okay, so from 0 to L. So if you can observe, your maximum loading is constant, right? Because it is supposed to be a value, but we are not given what value that is, but we know that that is constant. So therefore, we will uh, take our W max outside, W max, and integrate it from 0 to L sine pi x over 2L dx. Okay, so we will integrate this one. This is trigonometric function. So we let u is be equal to pi x over 2L. Du is equal to pi over 2L dx, and solve terms of dx, so this becomes dx is equal to 2L over pi du. Then substitute it here. This becomes the integral of sine u, and dx is 2L over pi du. So this becomes now 2L over pi integral of sine u du. Okay, then we substitute this back here. This becomes the integral of, and we have another constant being introduced, that is 2L over pi. So that's 2W max, maximum load, times L, which is our length, over pi, times the integral of sine u du. Now our sine, in differentiation, sine, cosine, negative sine, opposite po sa atong integration. So that's sine, negative cosine, cosine, sine. So this becomes, of course, we integrate that from 0 to L. So this becomes 2W sub max L over pi. And this becomes negative cosine U from 0 to L. And since U is equal to pi x over 2L, this becomes 2W sub max L over pi times negative cosine pi x over 2L. It become pi x over 2L from 0 to L. Okay, this is substitute 2W sub max L divided by pi. Now this, we take out the negative, so this becomes negative here. Quantity, so we substitute our L, that's cosine pi x becomes L divided by L. So that is, it cancels, so that's cosine pi over 2 minus cosine pi over x, pi, where x is equal to 0 is 0, so that's cosine 0. This is equal to pi over 2, that's 180, right? Pi, oh no, that's 90. Cosine 90 is 0. Pi over 2, that's 90. Okay, let us establish that. And cosine 90 is 0, while cosine 0 is 1. So this becomes negative 2W sub max L over pi times 0 minus 1. So our resultant uh, force F sub R is equal to positive, or what did it become equal sign? 0 minus 1. So this becomes positive 2W sub max L over pi. That is now our resultant force. And it has its unit is not specified. So whatever value our uh, loading W sub max B over, and also provide the length, then we substitute that, we will be able to get our resultant force. So this is our F sub R. Now, to find for our to find for this the location of our F sub R, so let us say uh, F sub R. Then from here to here, let us call that our x. No, since we are using variable x, let us call this as our distance. Do not confuse with the x variable being provided already. Okay, so for our moment, I will take moment. So our f sub moment summation, moment about point A. So that is our moment about R A is equal to the sum of all moment about A. Now you might be wondering that why I mentioned about moment when in fact the formula presented in order for us to find for the distance, its location, distance from a specific point, is this formula, right? The integral of x w x over w Now, if you can observe our numerator, no, sorry. If you can observe our denominator, which is the integral of w dx, that is actually our f sub r, right? So if we multiply f sub r back here, x w dx, this is our x, which is our distance, and this is our f sub r, which is our resultant moment, and that is equal to the integral of our x times its w dx, and that is the sum of all the forces that is, and not the sum of all forces, but the sum of all the moment that acts about your over your specified length, right? So in order for us, so therefore, what we can use is, pwede nato ni siya nga mo take tag moment. So, unsa man ang mga moment nga pwede nato ma-consider is that we will do uh, x times w dx is equal to the integral of x w dx. So this is x times f sub r, right? And x, of course, our w is w max sine pi x over 2l. So this is w max sine, sorry, sine pi x over 2l dx. Is this equal to x f sub r is, we know that w sub max again is constant, so we bring out w sub max. W sub max, and we are left with x sine pi over x over 2l dx. And by inspection, this we will use integration by parts to solve this one, right? So let us say integration by parts. So that is u is equal to x, du is equal to dx. We have dv is equal to sine pi x over 2l, and v is equal to, we will let another u here be equal to pi x over 2l, then du is equal to pi over 2l dx. Then we integrate it, so this becomes dx is equal to 2l over pi du. And sine is negative cosine, so this becomes negative 2, 2l over pi cosine pi x over 2l. Okay, so if integral of u dv is equal to uv minus the integral of v du, right? So this is equal to, our u is x, our v is negative 2l over pi cosine pi x over 2l minus our v, which is negative 2l over pi cosine pi x over 2L. Then our du is dx. So this becomes negative 2Lx divided by pi times cosine pi x over 2L plus, and of course 2L over pi is constant, so this becomes positive 2L over pi, the integral of cosine pi x over 2L dx. Then, wait, let me pan it here, wait, okay. Move a little, okay. Then we let, again, oh, u is pi x over 2L, du is pi over 2L dx, which is dx is equal to 2L over pi du. So our final answer, and we know cosine, the integral of cosine is sine. So this is equal to negative 2Lx over pi cosine pi x over 2L plus 2L over pi times the integral of 2L over pi. Oh, wait, let me write it like this. That's cosine u times 2L over pi du. Then 2L over pi paired with du is constant, so we bring that 2L over pi. This becomes now negative 2Lx over pi cosine pi x over 2L plus 4L squared over pi squared, and that is sine u, which is u is pi x over 2L. This is pi x over 2L. So of course, all of these are evaluated from 0 to L. From 0 to L. So this is 0 to L. 0 to L. Let me write it again here because I forgot 0 to L. 0 to L. From 0 to L. And then 0 to L. This is 0 to L. 0 to L. Okay. So we rewrite this one following the then we will copy all of these and equate that to our f sub r times x. So we bring down everything and this becomes aturang tunguron yun no, itungod. So this is somewhere here. Here. Okay. So that is x f sub r is equal to, now it is quite ingilad siya lang taon if maguna ang negative. So atong ibaylo sila maguna tag full L squared over pi squared sine pi x over 2L usa si cosine. And then this is 4L squared over pi squared sine pi x over 2L minus 2Lx over pi cosine pi x over 2L from 0 to L. Okay. And we evaluate x times f sub r is equal to, we have 4L squared over pi squared sine pi when x is L, so that's L over L, L pi over 2L, cancel L, so that's sine pi minus 2 minus 2L x, so that's 2L squared over pi times cosine pi over 2 again, parentheses, parentheses, minus 4L squared over pi squared. So if x is 0, so this is sine 0 minus 2L squared divided by pi, right? And, no, no, not L squared. Oh yeah, L squared times cosine 0. Okay. Now, pi over 2 again is 90. And we know sine 90 is 1. Copy. X times f sub r. So this becomes 4L squared over pi squared. Sine 90 is 1 minus 2L squared over pi. Cosine 90 is 0 minus 4L squared over pi squared. Sine 0 is 0. So this is 0 minus 2L squared over pi. Cosine 0 is 1. So this becomes now 4L squared over pi squared. Oops. But before I forgot, naapad ay tay W max, no? So, butang na lang nato diri si W sub max. Ayun. And kani silang tanan multiplied by W sub max. Okay, kani pud siya multiplied by W sub max. Okay. And then this becomes plus because 2L squared over pi times 0 is 0 minus 4L squared over pi squared times 0 is 0. So negative minus negative 2L squared over pi. So that's plus 2L squared over pi quantity W sub max. Okay. Okay, so before we continue, as I was reviewing my answers, this should be 0 times 0, 2L times 0. So this becomes wait, this becomes times 0. Why? Because we have 2LX. So in x is 0, then 2 times L times 0. 2L times 0 is 0. So it means our final answer should only be 4L squared W sub max, which is equal to our X times F sub R. Now, oh yeah, our X here is D. So we'll use D. This is equal to X is equal to D for distance, for our distance or location. So we will use, therefore we solve for D. So that's D is equal to 4L squared over pi squared W sub max divided by our F sub R, which has a value of 2W sub max L pi over pi. 2W sub max L over pi. So our D is equal to 4L squared over pi squared W sub max multiplied by 2W sub max L in our denominator, then pi. So cancel pi, so that's pi. We'll only be left with 1 pi in our denominator. Cancel W sub max, cancel 1L. So our distance is equal to 2L over pi. So whatever our length be, we multiply that out with 2 over pi. Okay, so yeah, this is how we calculate for our resultant of the system, provided our equation B, W sub max sine pi x over 2L. Okay, and our length is uh, L. Okay, for example 27, so just follow, I'll give you guys, uh, I will give this to you guys as para ma-solve ninyo, no? Okay, so we'll just use the technique that we have for example 23, I believe. Yeah, yeah, 23. You can have two options for this one. You will have two shapes, rectangle and a triangle, or if you want, you can have it both triangles. Okay.